begin talking about complex numbers. So what we learned so far, we start talking about natural numbers, then we introduced whole numbers, then we moved to integers, rationals, irrationals, then reals. Objective, complex numbers. So recall that we said, well, we have natural numbers, n, which is the set 1, 2, 3, 4, 5, and so on. We said that this set is included in another set, which is the integers. But before integers, we introduce the whole numbers. Let's write down whole numbers. Let's do not exclude whole numbers. It starts from 0, 1, 2, 3, 4, 5, and the rest of the numbers. Then we see we don't have any negatives here. Well, we add negatives and we call it integers. So for integers, you either use z or I. Z is ... -3, -2, -1, 0, 1, 2, 3, and the rest of them. Then we see we don't have any, for example, fractions here. We don't have any pi. We don't have any square root. We define rationals and irrationals. We say that this set is included in a larger set which has rationals and irrationals. So here you have your rationals, Q. And also you have another set, which is the set of irrationals. And all of these are included in a larger set that we call real numbers. Along with QC, we get your R. Real numbers. So a portion, let's just write down a portion here. QC, irrationals. Like square root of 2, pi, Napier number, negative square root of 7, and so on. So all of these are included in real numbers. But we saw that by solving x squared plus 1 equal to 0, we get x squared equals to -1, or x becomes square root of -1. If we use a calculator to calculate this guy, you get an error. If we use a calculator to calculate square root of -1, we get error. Don't believe me? Try. So when we have something like this, we're intrigued to define something new. It's not a real number. If it was real, the calculator won't generate error. So what's the meaning of that? It means that as a mathematician, I'm interested in creating a new mathematical object. I'm going to create complex numbers. Let us construct complex numbers. So what do? We're going to say that a complex number is written this way. A plus I times B. A is a real number. B is a real number, and I is defined as a square root of -1. So we have the real portion and we have the complex portion. So this one is your complex portion. This is the real portion, and this is the complex portion. Real part and the complex part. So again, if you use your calculator, calculate the square root of -1, it gives you an error because it's not a real number. We define a new number system. We call it complex numbers. Complex numbers have all of these sets included in itself. So we define this complex number. It has a real part plus a complex part. Very good. So we have complex numbers. As we add, subtract, multiply, and divide other numbers, we're going to do the same thing for complex numbers. Complex numbers. So algebra on complex numbers. First of all, we're interested in adding complex numbers. Addition. Let A plus IB and C plus ID be two complex numbers. Can I add these two? Of course, why not? We can add these numbers. Well, how do we add them? Okay, what you're going to do, you're going to add the real part and you're going to add the imaginary part. So A plus IB plus C plus ID, it's going to be A plus C plus I, parentheses, B plus D. Okay. Give us an example. Sure. Question says, add the following. Let's follow the note. We have 4 plus 7i. 4 plus 7i, or I times 7, plus 1 minus 6i. Okay, very good. So real parts, 4 and 1. Add them together. It's going to be 5. Then add the imaginary part. 7i minus 6i, 1i plus I. So this is your complex number. Another one. Suppose we're interested in adding 1 plus 2i, 3 minus 2i, plus 3 minus 2i. Okay, real parts, 1 and 3. which is just 4. Imaginary parts, well, I have 2i minus 2i, they are opposite of each other, plus 0i. Or you can simplify this and write it as just 4. We added 2 complex numbers and we got the real number. That's absolutely fine. So guys, this is C. I wrote B by mistake, it's going to be C. So let us talk about subtraction. Okay, I'm going to do the same thing for both of these and find a subtraction for these 2 numbers. So if you have subtraction, just be careful. Why is that? Because of the negative sign, subtraction. So let A plus IB and C plus ID be 2 complex numbers. We can subtract them, find the difference between these 2 numbers. We can find the difference between these numbers. But how? You copy down your first complex numbers minus, you have to put the second number in parentheses because it has 2 parts. It has real part and it has imaginary part. You have to distribute this minus sign into 2 parts. So minus C minus plus ID, which is equal to A plus IB minus C minus ID can be written as A minus C plus I B minus D. Very good. So let's just subtract these. Find the difference between these numbers. Find the difference between these complex numbers. Subtract the following. Okay, subtract the following. The first complex number minus, guys, be careful. When you have subtraction, always put the second complex number in parentheses. Then you have to distribute the negative sign into parentheses, so distribute. Very good. So what do we have? We have 4 plus 7i minus 1 plus 6i. Very well. 4 minus 1 is 3. And 7i plus 6i is 13i plus 13i. This is the result of subtraction between these 2 complex numbers. Let's put it into circle so we know this is our final answer. The second one, the same process. Put a negative sign between these 2 complex numbers and use parentheses. We have to distribute this negative sign, negative 3, negative, negative 2i. Well, okay, we have 1 plus 2i minus 3 plus 2i. Very well. 1 minus 3 is negative 2. 2i plus 4i plus 2i is 4i. This is our final answer, subtraction. So far we talked about addition, subtraction, now multiplication. How do we multiply complex numbers? We have to go back to algebra to find the multiplication between two complex numbers. So I'm going to leave these here. I'm going to repeat the same thing for these two numbers. So multiplication let A plus IB and C plus ID be two complex numbers. The multiplication is written this way: A plus IB times C plus ID. Here we have to use distribution. First, we distribute A into second parentheses, then we distribute IB into the second parentheses. Okay, let's see what we have. I'm going to use the same color for distributing A into parentheses. We get AC, A times ID, which is plus I, A plus. Now I'm going to use blue for distributing IB into the second parentheses. IB times C gives us IBC. And I'm going to multiply these two plus I squared BT. Quick note. We learned that I is equal to square root of -1. So I squared is always -1. Wherever you see I squared, you have to write -1. So what do we have? We have AC plus I parentheses AD plus BC minus BD. I squared is -1 or just negative sign. So this becomes AC minus BD plus I AD plus BC. Multiplication between two complex numbers. This is the general formula. Very good. So let us multiply the following. Our job is to try to multiply these. Multiply the following. The first one times the second one. So what are we going to do? We're going to start distributing. Distribute 4 into parentheses, then start distributing 7i into parentheses. 7i into parentheses. Okay, so 4 times 1 is 4 minus 24 times I. So far, so good. And now distribute 7i into parentheses. You get 7i times 1, which is 7i. And you have plus minus 42i squared. Okay, let's see. What do we have here? Guys, you have I squared, which is -1. Negative times negative becomes +1. So far I have 4 minus 24i plus 7i minus becomes plus 42. That's the transformation that we see here. So we have 4 plus 42, which is equal to 46. And here you have -24i plus 7i. We do the subtraction between these two because the larger number is a negative number. So we get negative.
Wait, can I ask what happened to the I squared?
Yes, I squared is -1.
Oh yeah, I didn't see that, sorry.
I squared is -1, so negative times negative gives you positive. You get rid of I squared, you get rid of this negative, So you get a positive real number. So this is 1479. Very good. So we get 46 minus 17i as the final answer for this multiplication. What about this one? Let's multiply these two. So what are we going to do? We're going to distribute 1 into parentheses, then we're going to distribute 2i into parentheses, one by one. Just observe carefully. 1 times 3, 3. 1 times negative 2i, negative 2i. Now let us start distributing 2i into parentheses. Plus 2i times 3 is plus 6i. Plus 2i minus 2i gives us negative 4. I times I is I squared. What is I squared? I squared is negative 1. Negative times negative gives you positive. So this guy becomes 3 minus 2i plus 6i plus 6i plus 4. Guys, negative 4i squared is negative 4 times negative 1, which is positive 4. This happens here. So 3 plus 4 is 7 minus 2i plus 6i plus 4i. So the same here, negative 42i squared, negative 42i squared. I squared is negative 1. Wherever you see I squared, you copy negative 1. Negative 42 times negative 1 is positive 42. And the last operation is division. How do we divide two complex numbers? So, division. If I ask you to divide a plus bi by c plus di, you have to follow the same process of finding a conjugate of the denominator, multiply both the numerator and the denominator by that conjugate. So, to simplify this division, follow. You take your fraction, a plus bi, divided by c plus di, and multiply it by the conjugate of the denominator, c minus di, c minus di. Multiply, and then multiply. This is the method that we use when we are dealing with the division between complex numbers. This guy is called the conjugate of the denominator. So c minus di is called the conjugate of c plus di. If the operation is addition, the conjugate has subtraction. if the operation is subtraction, the conjugate has addition. So they have opposite operations. So just let me use a different color. C minus I di is called the conjugate of C plus di. Everything is the same. C is the C, di, but you have an opposite operation. For example, here's an example. What are we talking about? Example. Suppose I ask you to divide these two numbers. Let me go back to the example that they had. 1 plus, let's just write this guy down. 4 plus 7i divided by 1 minus, let's just write down 1 plus 6i. 1 plus 6i. So you have two complex numbers. My first complex number is divided by the second complex number. To simplify this division, follow. Okay, I'm going to follow. What's that? I'm going to copy down these two numbers, 4 plus 7i, and I'm going to use a long division bar, 1 plus 6i, and multiply both the numerator and the denominator by the conjugate of the denominator. Guys, I don't need the conjugate of the numerator. I need the conjugate of the denominator. Why? Let's check. What do we have? Multiplied by 1 minus 6i and 1 minus 6i. C minus di, C minus di. Okay. Multiply, multiply. We have multiplication to do. This guy is equal to long division bar. Well, multiplication. Here we go. So 4 times 1, 4 times negative 6i, you get 4 minus 24i. 7i times 1, 7i times negative 6i. So we get plus 7i minus 42i squared. So this is my numerator so far. What happens to the denominator? The same process. 1 times 1, 1 times negative 6i. Okay. 1 minus 6i. 6i times 1, 6i times negative 6i. So I get plus 6i minus 36i squared. There you go. What is I squared? I squared is equal to negative 1. Wherever you see I squared, you have to simplify that using negative 1. So this guy becomes four minus 24i plus 7i plus 42. The denominator becomes 1 minus 6i plus 6i, they cancel out each other. 1 plus 36. That's why we multiply by the conjugate of the denominator. As you can see on your denominator, you're left with a real number. So this guy becomes 4 plus 42, 46, and minus 17i divided by 37.